Lesson 7, Exercise 7G, Using a Regression Line to Make Predictions. The learning goal for this exercise is to show how the regression line can be used to make predictions about the bivariate data that has been provided to us, and to further look into interpolation and extrapolation. The success criteria is to successfully use the least squares regression line to make predictions and to determine if we are interpolating or extrapolating. The aim of linear regression is to model the relationship between two numerical variables by using the equation of a straight line. This equation can then be used to make predictions. As a general rule, a regression equation only applies to the range of data values used to determine the equation. Thus, we are reasonably safe using the line to make predictions that lie roughly within the data range. The process of making a prediction within the range of data used to derive the regression equation is called interpolation, and we can have some faith within these predictions. However, we must be extremely careful about how much faith we put into predictions made outside of that data range. Making predictions outside that range is called extrapolation. Here we have an example of the amount of time spent in hours of study versus the mark in percentage that a student or set of students have obtained. This is put into a scatter plot, as shown here, and a least squares regression line has been fitted within that scatter plot. Within the scatter plot, it's safe to say that we can make a prediction of what a student's mark will be dependent on how much time they spent in hours. However, when we go beyond the last data point for hours, which is just before 40, if we go beyond that and make that prediction, we are said to be extrapolating this data. Because if you look at this line, we are assuming that somebody that spends 70 hours of time for study is going to get a mark of around 150. And you can't get 150% within a test. This line here, the least regression line, is unreliable because we are going beyond the data range, so we are extrapolating. However, it's safe to make a prediction within this data set because we are interpolating this data. We are making an assumption provided that we are within the range or the interval of the lowest and the highest. So we are safe to say that somebody that spent 30 hours of time studying will get a mark of 80%. And remember, this is just a prediction based on the data that has been given to us. It's also worthy to note that we will also be considered extrapolating if we go beyond the highest mark and also before the lowest mark. Or not mark, sorry, beyond the highest time and before the lowest time. Anything past those numbers in either direction is also extrapolating. We'll be looking into this example here where an equation has been provided to us. This equation is, the data has not been provided, but the equation has been provided, and what it says is that the weight of somebody can be provided that they give us their height. So a group of students, their heights range from 163 to 190. So the lowest is 163 centimeters. And the highest within this range, the highest is 190. And so all this means is that when a survey was conducted and the students provided their weights and their heights, the lowest height was 163 centimeters and the highest height was 190 centimeters. Within those set of data points, we don't know how many students had provided this information, but it doesn't matter because the least squares regression line was created and an equation was formed from it. And this is saying that the height, if you were to give a height, which is your explanatory variable, we can provide or make a prediction of the weight. So this will be the response variable. The height will explain the response, which is the weight. So we're going to use this equation to predict the weight in kilograms of a student with the following heights, and we're going to determine if it's considered interpolating or extrapolating. For A, we're going to make a prediction of a student's weight if their height is 170 centimeters. So we're going to find the weight given the height is 170 centimeters. So our equation, I'm going to use W for weight. So W is equal to -40 plus 0.6. Now it's key to note that you can have a negative y-intercept, or in this case w-intercept. This is possible, okay? Because it's just based on the provided data and the type of variables that we get within the data. So this is equal to -40 plus 0.6 times the height, which I'm going to put as h. So -40 plus 0.6 times whatever our provided height is, in this case is 170 centimeters. This ends up being 62 kilograms. So right now we have made a prediction that if someone is 170 centimeters tall, it's predicted that they will weigh 62 kilograms based on this linear regression line. And the 170 centimeters lies within the range of 163 to 190 from the provided heights. So in this case, this is interpolating. We have faith within this prediction because it lies within the range. For question B, we're going to predict the weight of someone whose height is 65 centimeters. So in this case, we're going to find, I'm just going to put W for shorthand notation. We're going to find W given the height H is 65 centimeters. So the weight is -40 times 0.6, and I'm just going to go straight to the number. I'm not going to write the formula out again. Times 65. So our weight in this case is -1. So this is saying that if you were to be 65 centimeters, you would weigh -1 kilograms. That doesn't make sense. How is that so? Well, you can now see the downfall of this equation that has been provided. Because 65 is lower than the lowest height that has been provided to us from this set of data, we are extrapolating. This is considered as extrapolating, and here you can see that this information is unreliable. In fact, it's impossible to weigh -1 kilograms. And this is why interpolating and extrapolating, and when you make your prediction, is such an important factor in making these predictions, because we can only rely on this line within this range. I mean, in fact, I wish I weighed -1 kilograms. I've been getting a bit tubby during this home isolation business. Maybe if I can shorten my height to be 65 centimeters, I could weigh -1 kilograms, but I don't know how I can do that. If you know of a way where, if you know of a shrinking machine of some sort, please tell me. Anyways, that's my rant over. This concludes this exercise. The log sheet for this is 7G using a regression line to make predictions. All you will need to do is questions 1 to 5. There are no calculator questions required, however you can use your calculator to help you out. I will see you guys in the next video.